Welcome back, guys, and as ever, I do hope during lockdown you and your family are keeping well. So we've been working on density, and what I thought I'd do as our last video is I'd have a look to see whether we could actually measure the density of a gas. So what we're going to do today is I'm going to do a quick experiment on how we might go about measuring the density of a gas. Now, I'm sure you remember that a gas has particles that are much, much further spread out. So we're expecting its density to be very low indeed. And the amount of gas that I can sort of take around with me in the lab in something like a balloon is going to be very small. So it's not going to weigh very much. So let's see if we can do an experiment to measure the density of a gas. So let's see how we go about measuring the density of a gas. Now, the amount of gas that I'm going to deal with today is going to be in a balloon, so it's going to have a very, very low mass. So I've got some different scales here, and these scales measure to hundredths of a gram. They're very expensive scales. And I'll read off what it says on the front because it's difficult to see on the video what it's reading. Okay, I'm going to use a balloon full of carbon dioxide, which is a fairly dense gas, but still much, much, much lower density than water because the particles in carbon dioxide in this cylinder, when they come out, are much further spread apart. So what I need to do is I need to work out the mass of the gas that I'm going to put in my balloon, and I need to divide it by the volume of that gas. So let's get started. So let's kick off with working out the mass of the gas, and then we'll do its volume. So to do its mass, I've got these scales here that measure to the nearest hundredth of a gram. I'm going to take my balloon, I'm just going to put it in this container, and then I only want the mass of the gas. So I either take off my full balloon value, I take off the value of this container and the balloon, but the easiest thing to do is to zero the scales. And it's difficult for you to see, but the scales at the moment are basically reading, it's very, very sensitive, but it should read 0.00 grams. So what I need to do now is I need to fill this balloon with carbon dioxide and put it on the scales again and see what mass of gas we've got. Okay, so let's put some CO2 in our balloon. So I'll hold it in front of the nozzle here and just gently inflate it. There we go. Be careful not to burst the balloon. So let's get as much CO2 in the balloon as we can without bursting it. There we go. So we've got a balloon full of carbon dioxide. And now for the balloon wrestling bit. So let's just tie up the balloon. And this bit is always easier said than done. So here we go. That's it. Okay. Now we've measured the balloon before in this container. Okay. And zeroed the scales. So when we put this on now, all it will do is measure the mass of the carbon dioxide in the balloon. Now there's not very much in there, so let's see what we get. Well, it's reading 3.3 grams, 3.38 grams. So I'll write that down, 3.38 grams. So that should be how much carbon dioxide we've got in the balloon. Just for interest's sake, I don't know if I can reopen this and let the carbon dioxide out slowly. Get in there. Okay, because I'd be interested to see what happens when we put the balloon back on. It's probably going to blow up in my face, isn't it? We're almost there. The gas out. Sometimes carbon dioxide sort of freezes. There we go. Okay, let all the gas out. And let's just see what the scales read now. Oh, that's fantastic. 0.01 gram. So it's basically back to where we started. So that's quite a good scientific check to show that the 3.38 grams of carbon dioxide we had on the scales really genuinely was the mass of the gas in that balloon. So all we need now is the volume, and if we've got the volume, then we can divide the mass by the volume, and that will give us the density of the carbon dioxide. So winding back the clock a little bit, we do need the volume of our balloon, and this is where it gets a little bit we fudge things a little bit. We assume that it's a sphere, okay? And we know that the volume of a sphere, you might not know this yet from your maths, but it's 4/3 pi r cubed, okay? So if I can get the radius of this, then I can get the volume of the CO2 in there. Now, not a particularly easy thing to do, but I like these experiments that are just sort of hand waving. So, I'm going to hold a ruler on here and put my hands on either side of the balloon. Okay, there are much better ways to do this, but I basically get a diameter. I'm getting a diameter here of about 23 centimeters. Okay, so if we've got a diameter of 23 centimeters, we've got a radius of 11.5 centimeters. So what we can do with those numbers is we can work out the volume of the balloon. We worked out the mass of carbon dioxide in it as well, and if we divide the mass by the volume, we've got the density of the gas. So I've come up to the board now, and we're going to work out the density of the carbon dioxide gas in our balloon. I've written a few things already just to get us going so that we know that density is mass divided by volume. We knew that the mass of our gas in the balloon was 3.38 grams, and the balloon's basically a sphere. Okay, a bit difficult for GCSE, but the volume of a sphere is 4/3 pi r cubed, which means we need the radius of our balloon. We measured the diameter at 23 centimetres, so the radius is 11.5 centimetres. And if we use that radius to work out the volume, we get the volume of the balloon, or the gas that was in it, of 6,371 centimetres cubed. So now for the important bit, let's work out the density of our CO2 gas. So the density is the mass, 3.38, divided by the volume of the balloon, 6,371. And if you do that, I'm sure you guess, you get a very small number. You get a density equal to 5.3 times 10 to the minus 4 grams per centimetre cubed. Okay, so that's a very small number indeed. And this is where it gets quite interesting, because the density of gases compared to solids and liquids is approximately, I'm rounding up here, 2,000 times less dense. And rather interestingly, if you work out what 1/2000th is, 1/2000th is 5 times 10 to the minus 4. So we've showed here that the density of our CO2 in the balloon is approximately 1/2000th the density of a solid or a liquid. So water would be about 1 gram per centimetre cubed, and this is about 1/2000th of a gram per centimetre cubed. So fairly simple apparatus, but that experiment worked really well. So I do hope you enjoyed that experiment and measuring the density of a gas. It's not something that school students normally see, so it's quite a fun experiment to do. and I don't really know whether you need that one for GCSE. There's a little bit more physics going on here. I have sort of avoided a few of the complications in this experiment, but I remember my teacher at school doing this with air and a big beach ball. It sort of worked. It gives us sort of the right answer that you want. Anyway, I hope you enjoyed that experiment and you have got an even better understanding of density now. And having looked at my previous videos, you understand how to measure the density of a regular solid, an irregular solid, a liquid, and now a gas. Anyway, see you next time.